module 1, construction, working and characteristics of FET, which is mostly the last second part of the module 1. So contents based on this: definition of field effect transistor, the types of field effect transistor, construction, working, characteristics, which constitutes of the two parts, the DC characteristics and the AC characteristic. Definition of an field effect transistor. The field effect transistor is a three-terminal device gate, source and drain. So these three terminals are controlled by an voltage applied between the input, that is the gate terminal here, gate terminal. So these are the two gate terminals and source and drain. So this is the basic definition of field effect transistor. The types of field effect transistor: N channel and P channel. So this is your N channel, which shows that the flow of the current is from source to gate. In P channel, the flow of the current is from gate to source. So types of these are the various types of your transistor, field effect transistor. Enhance metal oxide field effect transistor, drain metal oxide field effect transistor. So its type N type and P type. Similarly, enhance MOS metal oxide field effect transistor, N type and P type. See, you can see the flow of the current. It is from your drain to gate here. And for P type, it is from your gate to drain. JFET construction. N-type channel is formed. N-type channel is formed between the two P layers, which are connected to gate here. This whole structure is connected to gate. Majority current flows from source to drain. PN junction is reversed bias during normal operation. This results into wideness of the depletion layer and widens the N channel. Since the doping of P region is much large than the N region, as the depletion layer widens, the channel narrows and current flow is restricted. So this is overall construction of your field effect transistor, where you can see that gate to drain is forward bias and drain to source is also again forward biased. So both are in forward bias condition. Next, we'll try to understand the definition of pinch off voltage. So when VGS, voltage between the gate and a source, and voltage between the drain and source is taken into consideration, wherein VGS is largely greater than the drain to source, then under that condition, a little voltage drop across the length of channel and the depletion region are parallel as VGS is increased negatively and channel is closed. reducing the current ID to 0. This value of VGS is called pinch off voltage. So in short, if the gate to source voltage is very large as compared to source to drain voltage, a large voltage drop will be generated along the complete length of the channel. This is the length of the channel, and the depletion regions, these are the depletion regions which are parallel to one another, they will close and therefore no current will flow. So this is referred as a pinch off voltage. Current saturation region. What will happen is that in this case VGS is much larger than VDS. The voltage drop across the channel, depletion region, they are no longer parallel but they try to narrow down to some situation. This is the narrowing of the current depletion region. So here it has narrowed down. So when VDS is increased, they touch each other at some point and the drain current will reduce to 0. So this is your drain current that is flowing. So threshold pinch off voltage, which is VDS minus VP. The VDS increased beyond this, the drain current ID remains constant. So this is referred as current saturation. Drain characteristics. The drain characteristic is a plot between VDS and IDS. VDS and IDS. So in this situation, in order to plot this characteristic, the step to be followed is that the drain current is kept constant, drain current or rather VGS is kept constant. VGD is kept constant. VGS, this. So this is kept constant, VGS. By keeping this voltage VGG to some voltage, current ID is measured. So for suppose if I am measuring the characteristics at VGS is equal to minus 5 volts, then you can plot the output characteristic by varying this VDS and respectively measure the current ID. In the similar manner or in the similar fashion you follow for when VGS is minus 4, minus 3, minus 2, minus 1 and VGS is 0. Why do we say that after VGS we cannot plot the characteristic? Because in the previous slide you might have seen that when VGS is increased, this internal structure, these depletion regions which are there, they narrow down still and the current flow becomes 0. So it is as good as the circuit is in open state. That is why there will be no flow of current, that is drain current. So after VGS becomes 0, this drain characteristics cannot be plotted or this circuit will not perform. So transfer characteristic, it's a plot between the input voltage and output current. So here you can see that ID is equal to 0 when VGS is equal to VGS off, that is when it is 0 volts. ID is equal to IDSS by 4 when VGS is 0.5 volts and so on. So several situations are considered measuring keeping this VGS voltage to different values, that is 0.5, 0.3 and 0. Here from this graph it will make more sense or it will be more clear. So the overall drain current ID, this is equal to IDSS into 1 minus VGS by VGS of whole square. Relation between the transfer characteristic and drain characteristic. So this is your transfer characteristic, these are your drain characteristics. So when it is maximum IDSS, VGS is 0. When VGS is equal to 0 volts, that time you will find that a small small VGS voltage is existing, which is equal to minus 4 volts. So this will help you in plotting the nature of the output given the input signal. Nature, I'm talking about the nature. Nature means it can be a sinusoidal. Suppose if I take a sinusoidal signal at the input, I'll be able to plot the output characteristic. I'll show you how. So suppose this is my reference, okay, and I'm plotting my input characteristic. I am plotting my input signal. This is my input signal. I want to get the output signal from this. So what do? I take this particular point, draw a line across it, take this particular line, draw a line across it. Similarly, take this, extend this on this, and draw a line across this. All right. So this being my reference, this is my actual output signal. Given the input signal. So this will help you in plotting the output signal given the input signal. So this is referred as your this is how your transfer characteristic will help you in understanding how your respective input and output signals are related. That's all. I have completed my session.